Hello and welcome to Unit 7. In the previous unit, we derived the Lorentz transformations. These equations let us translate from one inertial reference frame to another. In particular, if we have an event in space-time, and it will have space-time coordinates in one reference frame, we can figure out what the space-time coordinates are in another reference frame using the Lorentz transformations. So they translate from reference frame to reference frame. In this unit, we're going to use the Lorentz transformation and two observer diagrams to think about a phenomenon called length contraction. And the starting point will be to think about what we even mean by the length of an object in the first place. It seems like an almost silly question. Well, like length is length, how long something is. But we want to express that idea of length in terms of events, because space-time diagrams, the Lorentz transformation, special relativity focuses on this notion of events. And so the definition of length, and I'll illustrate this with height, but it's the same thing, is the distance between two simultaneous measurements of at either end of an object. So the idea is we figure out what this point is in space-time, and then what this point is in space-time, and then we would subtract the two, and that would be the height of Anastasia. But the catch is that those measurements must be done simultaneously. So we can't, say, measure down here, and then come back a minute later, and maybe she's in the middle of a jump, and then we would measure her height as something different. So the key thing is that the measurements for length or height or whatever have to be done simultaneously. And you can see perhaps where the trouble or interest is going to come, which is that simultaneity is relative. So what Anastasia might think is simultaneous, Beowulf moving at a speed beta would not think is simultaneous. So again, the length of an object is the distance between the space-time coordinates measured simultaneously at either end of that object. In the next video, I'll derive a formula that will let us think about how lengths change from reference frame to reference frame.